So in this series that I'm starting today, we are going to look at the way we can implement high availability in a database management system. We will install Postgres. We will configure more than one Postgres servers for high availability. We will apply continuous backup and zero downtime disaster recovery, which is part one. We will use vagrants to manage our local or virtual machine, virtual boxes, to sort of emulate an on-premise local network. We will also install Postgres. Let's go to vagrantfile.com. Yeah, we will use vagrants to create and manage virtual machine. We will also use Postgres as a database management system where we will not only install Postgres, but we will also configure Postgres in different configuration, and we will create a user on server A, server A, which will be one of our virtual machine. We will create a user with authentication credentials. We will create a new database, set up Postgres host-based authentication to allow server A to connect with server B, which is, server A being a primary server B, which is a standby server. We will also revoke permission from Postgres user to authenticate on the newly created database. And last but not least, we will test that server B can connect to server A using server A authentication credential. So without further ado, let's go to Vagrants. If you want to download Vagrants, just go to vagrantsapp.com/download or use this URL. On Mac, you can easily install from brew install Vagrants, or you on Windows and Linux. Pretty simple. As soon as you install Vagrants, just go to your terminal, make sure that a Vagrants is installed. Right? When Vagrant is installed, you just issue the command Vagrants. You will see the automatic help, documentation explaining you or giving you details about different options to use so you can create Vagrants. Okay, let's create our folder where we're gonna, let's name the folder Postgres high availability. This is the folder where we are going to create our vagrant file. So let's create the vagrant file, touch vagrant file. And the vagrant file is sort of the main file where the configuration, where you need to write code as configuration. Okay, you can look at the documentation and see how you can use vagrants file. Okay, I'll go on tutorial. What is vagrants? Okay, but let's create our vagrant file so we can launch the two virtual machines that we needed to create a primary and a secondary server. Okay, we can open our vagrant file on VS Studio. There we go, that's our vagrant file. Now we need to configure, write the code that will automatically find a virtual machine for us and launch it. We start with the main namespace vagrants, configure, we pass 2, do config. Now we need to create our face configuration for the face or virtual machine. We defined our face, and we can pass any variable, sort of define our virtual machine. We can name it similar, or let's call it symbol. Okay. This will be the primary server. We just name it, and we can, as soon as we define this the variable, we can continue using the variable symbol vm box equal ubuntu Bionic 64. Now we need to set up the network. So if we launch our VM, our virtual machine, on this operating system, I'm using Ubuntu, the VM running as guest operating system won't be able to broadcast or to connect to the host unless we instruct vagrants to configure the network power forwarding. So the reason why we have to set this on network for forwarding, and if the guest has a port 5432, which is the default port for Postgres, we want the host to also use 5432. The host IP should be the host IP. This is my host IP, this is my IP, and if you are use yours. We also padding the autocorrect. We just passing the auto correct just in case there is a collision. We want our vagrants to handle that and to correct automatically when we're launching the virtual machine. Let's continue. VM network. Our private network, we want to use the type for this to use DS dynamic protocol, or this protocol is in charge of dynamically creating IPs. We can use that, or we can just use static IP network. Let's use the private network IP 192.168.56.4. Okay, that's for our network. And in this case, where we pass the name of our virtual machine vm.box, we are telling vagrant to go find this image on vagrant's public repository. Okay. Now, since we be using continuous backup configuration throughout our series, we want to make sure that we mount a driver in our virtual machine, and that driver can be shared with locally, in the network. And but the data of this driver will be host on the host operating system. So let's create let's name this create a share folder / driver. Okay, VM sync folder, home, Kula, that's my username, pg backup driver, pg backup driver. So what we are telling vagrants here, creates a driver name or a folder name, pg backup driver, under this virtual machine that you'll be launching, and this folder will create a sym link to the host on home, my username for the pg backup driver. Okay, you will see when we will use the continuous backup on Postgres. You will see we use this folder to kind of like a backup or to archive all our raw files, the raw head logs files. Okay, you will see the importance of this folder. Next, we need to configure the provider. So vagrants need a provider in order to launch your VM. So we'll be using virtualbox as a hypervisor, where vagrants will launch our future VM. So what we're telling vagrants here is that when you're launching the VM, we want you to get the ID of this VM and immediately apply the network address translation and resolve the DNS for the host. DNS host resolver 1. And this configuration should be on. Now we need to set the memory for this VM will be 2000 MB, 2000 megabytes, which is approximately close to 2 gigabytes. But if we put 2024, it's gonna be 2 gig. CPU, we're just gonna use one CPU, and we end configuration for this one, and we end configuration for the provider, and we end configuration for this VM. Since we need 2 VM, we're gonna configure another one. Config VM define. This one we're gonna call that Kambove. Kambove is just a variable, just a name. You can name that whatever you want. Kambove. Standby server. So Kambove VM box, we will use the Ubuntu Bionic 64, the same operating system. VM network, the forwarded ports. On guest we have 5432. On host we have 5432, the host IP. And you can create a variable for this host IP and then pass it, but I'm just using that as a layer of value. 192.168.1.74 autocorrects true, even if we are sure that the chance of a conflict is very small, but we just want to make sure that it's gonna autocorrect just in case. We're gonna create another forwarded port for the port 80. This means that if the VM is using port 80, to listen to that, you need to use 8081 on host. That's the guess that the host port. Host IP 192.168.1.74 autocorrects true. Network configuration. Now we don't have to use. We want to make sure that we are pointing to Kambove, not Simbulu. It's gonna create a conflict. Let's go to Kambove VM provider. Still, the provider will be virtualbox. VB customize modify VM get the ID of the VM and use the network address cancellation as a configuration for that particular VM. Also resolver 1 on VB memory 1800 VB CPU 1 end configuration. We end configuration and we end configuration for our vagrant namespace. That's the file that we'll be using to generate 2 VM. Let's go ahead and launch our 2 VM. To do that, we can save the file, make sure that we have the file here, and we're just gonna issue vagrant app. The name of the first one is Simbulu. Oh, we have an error on line 5, right to guess. There is no comma. So let's go back, fix that. Yeah, we need comma here. Save. Go back. Vagrant app Simbulu. Now we are creating our machine, virtual machine named Simbulu, which is gonna be our primary server. So what Vagrant is doing now is going out there, download Ubuntu Bionic image and install that onto the provider VirtualBox by applying all the configuration we've written as code. I'll pause here for a while and then I'll be right back. We just launched the Simbolo. Now let's launch the standby server, which is Kambove. There is an error on Kambove. Let's go back, fix that. Now we gotta launch the Kambove. Kambove will be our standby server as we progress towards configuring replication between two Postgres servers. As you can see, Vagrant was able to fix the power collision, but he didn't find any error, so he sets port 5432 to port 5432 on the host. Okay, we are done launching our second server, the Kambove. So to make sure that both our Simboli and the Kambove server are running, we can just SSH vagrant SSH to Simbolo. Okay, we can now SSH onto Simbolo, which is our primary server. As you can see, the IP is 192.168.56.4. We can also check with if config. As you can see, the IP, that's our primary server. Now, if we want to SSH onto our secondary server, we can use vagrant SSH Kambove. If config, yeah, it looks like a Kambove doesn't have a correct IP on the same network with it doesn't have the same private IP. So we need to set up an IP for Kambove VM network, private network, IP 192.168. They should be on the same network, .56.11. Okay, we saved that. Now we need to reload Kambove. We're gonna reload Kambove. Now we are reloading Kambove, applying new settings and recreating network. As you can see, Vagrant is shutting down Kambove VM and reapplying new settings. As you can see, clearing any previous set forward port. Fix collision, there is no collision, so it's gonna use the defaults. Now if we SSH onto Kambove to make sure that Kambove and Simbulu are on the same network, if we issue if config, as you can see, Kambove is on network 192.168.56, which is the same network as which is the same network, the same network as the Simbulu. Simbulu is on network 192.168.56. That's our configuration. Just we need to make sure that we change the host name because they both has the same host name, Ubuntu Bionic. Let's just quickly change the host name and dismiss for this video. Sudo nano etc host name. This was for Kambove. So it's gonna be Kambove server. And we also need to change the host name on etc host. Replace Ubuntu Bionic to Kambove server. Let's continue. Yes, continue editing. Kambove server. Kambove server. Okay. We can exit. Okay, let's go to Simbulu. Simbulu has the same name Bionic, so we have to make sure we're on Simbulu if config 192.168.56.4. That's our primary server. Sudo nano etc host name. We will name the Simbulu server. Save, exit. Let's go to etc host. We will name the Simbulu server. Simbulu server. We can exit. So now that we have exit, we can we could have reboots to confirm that the host name has been changed. Just use the gracefully by using vagrant reload Simbulu or vagrant reload everything, which gonna reload both our primary server Simbulu and our secondary server or Kambove. Okay, now that we have reload the configuration since we've changed the hostname, let's SSH to each one of our VM so we can make sure that the hostname has been changed. We will SSH to Cambover, which is our future standby. As you can see now, Cambover server, and if we SSH to Simbulu, as you can see now we have Simbulu-server. Guys, I'll conclude this video here. The next video I will install Postgres on both servers. Make sure that a server or the standby server, the future standby server Cambover can connect to Simbulu, read a database and write onto a database. Thank you for watching. I'll see you in the next video.